Hey guys! In this video, we are going to introduce what an exponential function is. So we have seen two different types of functions already. Our first type, we have that y equals mx plus b, which we know are linear functions. And then we have ax squared plus bx plus c is our quadratic functions. So our linear functions, we know that those have an exponent of 1, right? So the exponent on that x variable is always 1. In a quadratic, the exponent is 2, where we always have that x squared part. Now, let's think about how we get a linear function. So an example of a linear function would be to start at 2 and add 3 each time. So if I start at 2 and then I add 3, 2 plus 3 would give me 5. 5 plus 3 would give me 8. 8 plus 3 would give me 11, and 11 plus 3 would give me 14. Now, what is our slope in this type of linear function? How much is it changing each time? Well, each time it is changing by 3. And then we remember that our y-intercept is where it's starting. So the starting value of this is going to be 2. So we could write the equation y equals 3x plus 2 to get a linear function. So the key thing I want you to see here is that in a linear function, you are adding some value every time or subtracting some value, but that change is going to be the same. In an exponential function, an example of an exponential function would be to start at 2 and multiply by 3 each time. What do you see as the difference between the linear function and the exponential function? The difference between the linear and the exponential function is that in an exponential function, you are multiplying by 3 each time. So if you're starting at 2, I'm going to go times 3 and we're going to get 6. Then I'm going to do times 3. 6 times 3 is 18. Then I am going to go times 3, and 18 times 3 is 54. And then 54 times 3 is going to be 162. So you notice that the first one we added 4, then we added 12, and every time it's increasing by more because we're actually multiplying the values. If we wanted to write this as an expression, we might say that this first one was 2 times 3. Then we did 2 times 3 times 3 again, which we could also write as 2 times 3 squared. To get 54, we would do 2 times 3 times 3 times 3, which is 2 times 3 cubed. And for 4, I would do 2 times 3 times 3 times 3 times 3 again, because we multiplied by 3 to get that new term, which would be 2 times 3 to the power of 4. So now you notice that the type of term that we have is actually the exponent of our value that we're multiplying by. So we call this an exponential function because the thing that's changing is actually the exponent. The exponent is what is changing. In an exponential function, you have an initial value, which is where you start. In this case, we started at 2. And now, are our numbers getting... Exponential functions can grow or can decay, kind of like our lines can have a positive or a negative slope. So a growth is going to be that the numbers are getting bigger. Decay means the numbers, as we go up in our terms, are going to get smaller. In this case, this was growth because our values got bigger every time. And the growth or decay factor, that is this number right here. It's what we're multiplying by to get our new term. In this case, that is 3. So we could write this equation as y equals 2 times 3 to the power of x, because that is how many times are we multiplying by 3. Whereas here, it was how many times are we adding 3. So, because remember that exponents are just repeated multiplication. So this is the general form of an exponential function. Y equals a times b to the power of x. So you notice that your variable, the variable is in the exponent. That is super, super key. Your variable x, your input, is in the exponent. Now that a is going to be what we call the initial value. It is what you start at. It is where your function starts. So when a lot of exponential functions are used in real-world scenarios, and your a is going to be what the starting value of that scenario is, and then your b is going to be your growth or decay factor. And that tells us how quickly our value is going to grow or how quickly our value is going to decay or get smaller. And then we know that y is our output because x's are the input. Remember, these are our vocabulary terms for domain and range. So let's first practice identifying the input and the growth factor. So what do you think the initial value is in this first example? Remember, your initial value is the number that is not raised to an exponent. So in this case, the 2 is our initial value. Now, let's think about what happens as we multiply by 1.5. 2 times 1.5 is 3. 3 times 1.5 again is going to be 4.5. So my numbers are getting bigger. That tells me that this is our growth factor. Because as I keep multiplying by 1.5, my output y is going to get bigger. Let's look at another example. In this case, my initial value is 1/2. And then my growth or decay factor is going to be here. Now let's think about if you multiply something by 3/4. 3/4 of 100 is 75. So that's actually getting smaller. So we would call that a decay factor. Finally, we have this example, 1000 times 1.005 to the power of x. Once again, 1000 is still our initial value. And the 1.005 is going to be our factor. Now, is that going to be growth or decay? Now, 1.005, I could even use my calculator. And if I did 1000 times 1.005, that gives us 1005. 1005 is more than we started with. It's just a little bit more, but it is more. So we know that this is going to be growth. So you notice that if I'm multiplying by a number that is more than 1, it's going to be growth because it's getting bigger. And then if I multiply by a number that's less than 1, like 0.99, that's going to be decay because the numbers are going to get smaller. So if the rate of change is more than 1, it's growth. If it's less than 1, it's decay. And that is an introduction to exponential functions.